Welcome to the Data Ductus in-core video series. This installment is about our service prioritization, service level agreement, SLA, and key performance indicator management software called IN.Queue. For this demonstration, we will use Cisco's Network Service Orchestrator, also known as NSO, as the server to which our client will be sending HTTP requests. When we send REST service requests to NSO, NSO processes the requests as they arrive. There is no organization, prioritization, or safety net when sending multiple requests simultaneously. This can cause serious headaches, such as waiting on requests to finish, needing to send requests one by one in a specific order, or even failure from flash crowding. INQueue solves these problems as it can handle prioritization of each request. The INQueue software utilizes the power of Apache Kafka and Vertex to manage service requests and put them into different priority queues. Using the software allows users to view performance metrics and ensure they are meeting service level agreements. We define a service request as any HTTP request sent from a client to a server. INQueue will take any service request with priority defined by the client and store it in the appropriate queue. INQueue has 3 priorities: high, medium, and low. As such, the service requests become organized and sent to NSO one at a time in priority order. Now, we no longer have to worry about sending requests individually. Instead, we can send multiple and give them each a priority. Follow along as we demonstrate INQueue in action. Here, you can see the main page displaying the 3 priority queues: high, medium, and low. These queues represent HTTP REST requests from our northbound NSO client. INQueue allows our client to give services different priorities. In this demo, we will be using INQueue to prioritize, manage, and send REST service requests to Cisco NSO. Above the progress bar panel, we have a tenant ID generator and search. We'll use this to access a temporary tenant page to display the workings and power of INQueue. We will use the tenant dashboard to demonstrate INQueue in action as we put NSO REST service requests into the different priority queues of INQueue. We can insert service requests for high, medium, and low. Normally, the client would send requests to INQueue through the northbound API. However, this dashboard gives us good demo capabilities to insert items into the queues manually. We will insert test requests into the queue and see the IDs returned by INQueue for the northbound client to use. We will now show the details of one of these test requests. Looking at this test request, we can see it is still waiting in the low priority queue, and the request is to get the resource at the path API/running. Let's see what the status of our service request is now. Here we can see that our request is complete, and the body attribute is the response for our service request from NSO. Let's take a look at our completed requests tab. This page displays important information about our requests that have been processed by NSO. We can use this page to see if we are reaching our service level agreements, how many requests we've processed through each queue, and how each request is performing. Metadata for each queue is displayed, giving us the average time of each request and the total number of requests that have been processed. The lower table displays information about each completed request. Let's see what the result of one of our requests was. We can see the response given by NSO under the body attribute. Let's go back to the submission page. To demonstrate an actual service request submission, we can use the HTTP request input box. Here, a custom request is inserted and submitted to any of the 3 queues. What if our high priority queue was always full? Would requests in the medium and low priority queues never get handled? This problem is called starvation. INQueue has been designed to handle starvation. It was built so that all requests will be processed. IN.Queue uses polls to check each priority queue and a crediting system that we can define however we want. Let's run a test and do that now. Here we will change the credits. As an example, a credit of 20 in the high priority queue will tell INQueue to only allow 20 requests to go by before it checks the medium priority queue. This is one of the methods INQueue uses to prevent starvation. The changes can immediately be seen as requests are being processed in greater increments than before. We can now see that the average time for each queue is changing as a result of the modification of the credit values. Thanks for watching this video on network transformation from Dataductus.